In this video, we're going to take a look at applying inverse matrices. We've already spent some time learning about what inverse matrices are, how to find them if they exist, and we spent a little bit of time applying them to systems of linear equations. So instead of doing an augmented matrix, which requires that row-reduced echelon form, we would find the inverse and then multiply it to our desired outcome to find our variable matrix. So just to put things in perspective a little bit, when you're finding an inverse matrix and you're doing it by hand, it is going to require a little bit more work than doing just that straight on reduced row echelon form. But the versatility that we get from using an inverse matrix is that you can apply that same inverse to multiple scenarios. Meaning when you have a business application, as we'll see here in just a moment, we can change out the desired outcome or the constraints for each equation, and we can keep that initial matrix of information exactly the same. And in so doing, let's see here. And in so doing, that allows us to, there we go. That allows us to say that when we have x is equal to our inverse matrix times our desired outcome or our constraints, or however this is termed, I just keep that inverse the same. I change out my B matrix each time, which then gives me a new variable set in terms of values. So instead of having to do reduced row echelon form, for example, 6 times, I only have to do this matrix inverse once and apply this B, change that B out 6 times, and just get a whole new set of results over and over and over again. So the process we're going to go through with applying inverse matrices in this setting, where you just have that one inverse and you use it multiple times, is we're going to set up a system of linear equations, creating our matrix equation from that, and then one at a time we'll change out that B matrix, that desired outcome, and we'll look at what happens with our variables. We'll get those new values each time. To start us off with our practice, we're going to take a look at example number 4 on page number 126 in your book. So let's see. Good. Here we go. So example 4 on page 126. So let's take out a moment to read this example, making sure that we start with a question, because that'll help us to figure out what we're supposed to be doing and what we're looking for, and then going back through to see what information has been given to us. So the question line is, how many rings, pendants, and bracelets should the company fabricate each month to use all the available materials and time? So this tells me that when we're looking at our variables are going to be the number of rings, the number of pendants, and the number of bracelets. So I'm just going to write that as just a little note for myself. I'm just going to go ahead and say that the first variable is rings. The second one is bracelets, or pendants, sorry. As I said, rings, pendants, and then that third one is going to be bracelets. There we go. Okay. So now back to the top. An employee-owned jewelry company fabricates enameled gold rings, pendants, and bracelets. Each ring requires 3 grams of gold, 1 gram of enameling compound, and 2 hours of labor. Each pendant requires 6 grams of gold, 2 grams of enameling compound, and 3 hours of labor. And each bracelet requires 8 grams of gold, 3 grams of enameling compound, and 2 hours of labor. Each of the 5 employee owners works 160 hours each month, and the company has contracts guaranteeing the delivery of the grams of gold and enameling compound shown in the table on the first day of the months shown. How many rings, pendants, and bracelets should the company fabricate each month to use all the available materials and time? So now this means we're going to figure out how to create our matrix where we're going to be solving for the number of rings, pendants, and bracelets that uses what's required to make those three items, rings, pendants, and bracelets, and then also uses up all the available materials and time. Now the materials have been given to us in that table where it has March, April, May, and June as a column headings. And with regards to time, they tell us that there's 5 employees who work 160 hours each month, which means if we do 160 times 5, that'll give us the amount of time that's required. So just a little note here. The time is going to be 160 times those 5 employees, that's 800. So it's going to be 800 hours that's available. And then with regards to the materials that's available, that's just listed in the matrix. It's listed in that available materials matrix. So I'll just put matrix of materials. So now we need to figure out what's required for a ring, a pendant, and a bracelet to be fabricated. They've actually done a very nice job of taking all of those numbers in terms of grams of gold, grams of enameling compound, and hours of labor and putting it into a matrix for us already. So I'm just going to write that up over here, and I'm going to call this one our A. Okay, because this is telling me what's happening to create these 3 items. So I have 3, 6, 8, 1, 2, 3, and then 2, 3, 2. Okay, so this is my production matrix. This is telling me what's required in order for me to make a ring, a pendant, and a bracelet in terms of number of grams of gold, number of grams of enameling compound, and hours of labor. Now, keeping this in mind, I know that I have A, which means I need to figure out what my X matrix is. And that X matrix should just simply be those 3 variables, just like that. And now the B, our B matrix, I'm actually going to do this one a little bit differently. Meaning I'm going to write into this matrix area what values I'm going to expect to be in each of those rows. Okay, so if you look at the first row of matrix A, this is all relating to the grams of gold, right? So that means in matrix B, I want for this first row to be the number of grams of gold. So the amount of gold that's needed. Okay. In that second row, it's talking about the enameling compound. So it's the amount of enameling compound. So I'm just going to call it EC for short. And then in this third row, it's saying that that's relating to labor. And we said that the number of hours of labor, in this case, is going to be 800. So I'm just going to simply write it as number of hours of labor, just like that. But keep in mind that this number of hours of labor we already know is 800 right here. The amount of gold and enameling compound that's available actually changes each month. Just like how we said, when you're applying this equation and you're using your inverse matrix, that B matrix is going to change for each case. In our problem, in this particular example, the amount that's changing, the part that's going to be changing, is right here. These 2 values are going to be based on what month it is. So based on the month. Cool. So let's go ahead and write up our system of linear equations so we know what it is that we're working with to then understand how to set this up for each of our different months. So we're going to take this 1 month at a time. So solve 1 month at a time. I'm going to write up the first one for March, which I believe is also, there in the bottom of page 126 and then repeated on the top of 127. So we see that we'll have 3 times our number of rings, And then we have 6 sub 2, and then that 8. Okay, and we said that for the month of March, we're going to have 1,720 grams of gold available. So that's our gold line. Then we go to the next line, and it's talking about the amount of enameling compound that's required. And for the month of March, we'll have 600 grams of enameling compound available. And then when we look at labor in this case ends up being consistent because it's the same amount of time that's available each month. If it was changing, then you would want for this value to change as well. But in this case, it's going to be not 600, but 800. And that's the amount of labor time that's available for the month of March, and honestly for every month. So with this system of linear equations, it's going to be written as follows when you put it into matrix equation form. So there's your A of 3, 6, 8, 1, 2, 3, 2, 3, 2. And then your X matrix. And now for your B, I want to make sure you can see this so you understand this is going to be a part that's changing for each case. That B is going to be 1720, which is a number of grams of gold, 600 grams of enameling compound, and 800 hours of labor. And this is just for the month of March. Just for the month of March. So all this is talking about the month of March. Now, when you go to April, May, and June, it's going to be this end set of numbers that changes each time. So for example, when you're looking at April, instead of it being 1,720, 600, and 800, it's going to be 2,620. It's going to be 2,620. And they will have 960 grams of enameling compound available. But it's still 800 hours of labor because the amount of labor time, as far as we've been told, doesn't change for each month. So you would change these values out and you have a whole new system that you're solving for. You would change out these values in your equation, whole new system. Again, the beauty of using an inverse matrix is, like we said, when you're solving for that inverse matrix, and I'll just write this up here, right underneath, is that it's going to follow the form of solving for x is going to be your inverse matrix times that desired outcome set. So we are going to spend some time finding the inverse matrix, and then once we've found that inverse matrix, we're going to apply it to each scenario.